OK， 好，就让我们开始吧。So, hello everyone, I'm Ian. So today I will be talking about computer science, which is detailedly about sorting algorithm. So since today it's a AP calculus class, so actually I'm going to analyze sorting algorithms with calculus. I think that's pretty interesting to me. I think you guys will be interested in too. So let's move on. So first of all, I'd like to introduce you guys about like the plots of my presentation. Okay, so first I'm going to talk about the introduction of my research, and also I'll explain to you guys what's algorithm, and also sorting algorithm. Because since like for someone who's not studying computer science, I think that's pretty complicated for you guys to understand like what kind of stuff is that. So I'll explain to you guys too. And then moving on, I will tell you guys my research method and show you guys my data and make a conclusion. So let's start. Introduction. So first, in this research, I would like to analyze the sorting algorithm with calculus. And what I'm going to analyze about, I'm going to analyze the speed of each sorting algorithm and space that each algorithm require, and also the efficiency, like which sorting algorithm has the highest efficiency, which is like, yeah, it's the best one, and also the stableness, since some of the sorting algorithm is pretty fast, but in some cases they'll crack down. So yes, and at the very end, I would like to compare ON to calculus. Actually, so when we talk about a speed of a code program, we will use ON to record like how fast it is, and yes, I'll introduce you guys to ON too in later on in the presentation. So basically, I'll give you a small introduction. Is that when we talk of programming, we'll use ON to symbolize how fast the program is. And while I was like doing this, like why did I choose to do this topic is that I think that why don't we like I was curious about like why don't we use calculus to like symbolize how fast the program is, since we can say like the rate of change of this program, like when the data increase, then how fast does the speed increase or stuff like that. So why do we use ON not calculus? So this will be analyzed in later on in the presentation. So first of all, algorithm. So what do you guys think of when we talk of algorithm? Actually, this is a question. So anyone want to answer this? Like, no one? Anyone? Okay, then it's fine. Because actually, I interviewed lots of people, and when I asked them like, oh, what do you first think of when you think of algorithm? They like most of them answer YouTube and Google. So YouTube algorithm and Google algorithm. What's that in Chinese? We say YouTube 的演算法. So it's often heard in like YouTubers' videos, right? So they will say that they hope the YouTube's algorithm to promote their videos and make their videos popular and stuff like that. So when people first think of 演算法, this algorithm, people think that it's this thing about like promoting like YouTube video and stuff like that. However, that's not the case actually, because like anything with a sequence and instruction, it's called an algorithm. So I'll give you guys an example. I made this picture, so it's kind of like the quality is not that good, but yes, I made it, so it's I try my best. Okay, so actually this case will be counted as an algorithm too. So when a computer suddenly shut down, then what will we do? So we will check whether is it out of battery or no. So if it's out of battery, then we just charge it, then we can reuse the computer, right? And if it's not out of battery, then we will check it. Does the computer crack down or something like that? Is it fixable? If it's fixable, then we fix it. If it's not, then we have to consider buying a new computer, right? So actually, this process is an algorithm already. So anything with sequence, as you guys see, anything with sequence and like clear instruction is called an algorithm. So this is also algorithm. And okay, so after you guys understanding like what algorithm is, I'll introduce you guys what sorting algorithm is. If you guys, do you guys know what sorting is? Sorting in 中文 is 排序，所以 sorting algorithm in Chinese is 排序演算法. So 排序演算法 is kind of a kind of 演算法 that help us to 排序certain numbers. So this is often used in programming because like when we are like writing codes and like doing calculating numbers, it's very important if the array like bunch of number is sorted in a sequence. We like the number to go from small to big. It's easier for us to do calculation in programming. So sorting algorithm is like widely used in like programming. So as you can see here, like we are use big O notion to record the speed. Also you can use yes. So you guys can see that we use big O notion to record the speed, and also sorting algorithm can use lots of divide and conquer method, data structure, and binary tree. So actually sorting algorithm is like it contains all the like stuff in programming, like all the algorithm in programming will take parts of in sorting algorithm. Okay, so actually, so I'm going to analyze like which sorting algorithm has the most efficiency and which one is the fastest, stuff like that, right? So we have to choose like what kind of sorting algorithm we are going to analyze, compare about. So first one I choose merge sort, and second one I choose insertion sort, bubble sort, quiz sort, and selection sort. So for you guys that like did not like really started in computer science, this will be really confused to you guys. Like what kind of sort is that stuff? So I will show you guys a GIF picture so you guys can know basically what the sort is doing. So let's move on to merge sort. So as you guys can see, it's a random number, and first they'll group into different groups, and then combine and combine. So this is using a divide and conquer method. So I deal with a small section first, and then I deal with the next section, and then I combine both sections, and then I move on. So basically, I just repeat the step. I combine the small section, and combine them again to a bigger section, and combine them all together. That's a merge sort, and then insertion sort. So you guys can see that which like while time goes, like if I meet any like values, I just put it into the like sorted array. So it's like inserting value into the array. So you guys can see how the insertion sort goes. And bubble sort. Bubble sort is called bubble sort because it's like looks like a bubble in the code. So you guys can see that. Yes. Yeah, just all comes to the straight line, like a bubble. Yes. So this is a bubble sort. It is the easiest sort in programming. Like most of people use this. And also quick sort. Okay, and so you guys can see that this is a random number. Yes, and they'll compare to and swap, change the position. Yeah, compare the left and compare the right. So yeah, this is a long video, so we just skip it from here. This is a quick sort, and this is a selection sort. So you can see that they will pick value that's suitable for the next position. So yes, see. They will pick the value that's suitable for the next position and just put it in the array. So this is a selection sort. It will select the value, put it into the sorted array. Okay, so big O notion. As I mentioned, like we use the big O notion to symbolize how fast the program is. So how do you look at a big O notion? Okay, so for example, this one, O1. If it has one step, which I think most of us study in what's that called? Teacher Vivian's computer science class. So you guys will know what's this, like integer a equals to 0. This is one step, right? So it's O1. So the time efficiency is O1. And for this one, it's a for loop. It's go from 0 to n. So this one will have an n step. So then the time efficiency is O n. How about this one? It's a double for loop. So this will go 0 to n. So if n is 3, it will go 1, 0, 1, 2. So and inside it will also go from 0, 1, 2. So 3 times 3. So if n is 3, then 3 times 3 is 3 squared. So for this one, the time efficiency is O n squared n squared. So that's how you look at big O notation in a simple way. Okay, so finally I introduced like to you guys all about like the stuff in like my research, and so now move on to my research method. So, in the beginning, I have to create a program containing different kind of sorting algorithm and execution timer, right? Since I have to compare like the efficiency. So of course I have to write out the code. So actually, I'll show you guys my code. Okay, so here's my code. It's 268 lines long, and I'd like to ask you guys if you guys want me to introduce the code detailedly, because I know some of you guys are very interested in coding. So if you guys want me to introduce the code detail, then please raise your hand. If you guys just want me to demonstrate like the big ideas of the code, then just don't raise your hand. So anyone want me to introduce the code like in a very detailed way? Anyone? Actually, I personally want to though. Okay, just two of us. Seriously? Okay, so I'll then. Oh my god, but there's only two
杨明
of
这里
us.
还有4分钟哦。
Oh, then okay, then I don't have time to
Only 4
introduce.
minutes， 对，我觉得是时间的问题啦。
Okay, I'm sorry. Then I
之后
cannot
有机会再
introduce
让
the
你
code.
大讲。
Okay, so then I will just show you guys basically what's the code about. So here is the merge sort, and you guys can see all the insertion sort, bubble sort, quick sort, all the code. And actually, 递回 this method is often used in the coding. And also, you guys can see the timer. This is a timer, and this is like timer, and this is starting the timer. So you can see I start before I merge sort, and I do the merge sort. Then after I call the merge sort, so merge sort is function up there, right? So I finish the merge sorting function back again, then I'll end the timer. And later on, I'll print out the time. Print out the time over here, and also I'll print out the like array that I have already sorted already after each function ended. So I like to sort one array for you guys. So do you guys want to give me a random number, or I just generate it from here? So actually, because I have to generate a random number in order to have a data set, right? So I use this Google random number generator in order to generate a array of numbers. So there we go. So I would like to sort array for you guys to demonstrate. So that's how about let's go from. Okay, how about this? Smaller. This takes too much time. Just do a longer one. So here. So how many digits is here? 5 digits. So how about let's try. Let me see. Which sort? How about let's try a bubble sort? Okay, so bubble sort is number. Let me see. Bubble sort is number 2. So type in number 2, and there's 5 digits. And what's the number though? Okay, so 6, 5, 9, 4, 0. As you guys see, the array has been shoot. So as you guys can see, the array has been sorted. See, 0, 4, 5, 6, 9, and it took 0.00404 seconds to sort this array. So as you guys can see, it's very very fast since there's only like 5 digits in this. And actually, I've done a ton of stuff. So a ton of experience. So you guys can see this is all like the data I've done. So you can see all of them are. So yes, but it takes too much time to show you guys all of the data I have done already. So let's just move on. Okay, so shoot. Okay, so step 2, generate a random number array. So as I mentioned, I just used the Google random number generator to generate a random number array. So just as I show you guys, and also I input the random number array. So I just you guys see, I input the which sort that I want and how many digits in there, and also the number of the array into the program. So the program will give me a sorted array and also the execution time. And so the final step, I record and analyze the execution time and different sorting algorithm with calculus. Data analysis. So we'll move on to the data analysis. So this is the number I got. So as you guys can see, n is digit. So this is digit from number only 1 digit, and this is the time efficiency when we have 9 digits. And actually, I stopped at 9 because like my computer is like burning down. Like actually my computer cracked down when I do 10. So I think it's impossible for me to do later on because this sorting algorithm really requires CPUs and like computing stuff. So my laptop couldn't hold on to the higher digit of like calculation. So we might need a gaming computer or maybe a supercomputer in order to do the calculation, a higher calculation. My computer limit is to 9 digit. I'm sorry. So my data can only go from 1 to 9. And as you guys can see, this is the best fit line, and this is a plot of like each data. And so I want you guys to focus on two sort, which is a merge sort and selection sort. You guys can see merge sort here, the blue one. So you guys can see like the rate of change of it is really the what's that called? 斜率 is really steep, so it has like higher rate of change. And you guys can see the selection sort is bottom here, so like the rate of change of it is not that big. And here, actually, I want to draw you guys the rate of change, but I figured that it's impossible for you guys to see. So actually, special thanks to Anna and Yvonne because they helped me a lot for like drawing the what's that called, the f prime of this and f double prime of this, but it's impossible for you guys to see because I will show you guys why. So this is the scale in n equals to 1 and to 9, right? So this is the digit I input and this is the time in seconds. So as you guys can see, that's the graph of it, but it's impossible to draw a rate of change because here, I'll show you guys why.
好，Ian，Sorry for interrupting，要不要直接讲结论？好，因为已经超过时间喽。好，你讲结论，然后我们礼拜3有时间，我们你要不要再把它补完？好，我想说今天先让那个 Ann 先报告。好，所以你大概把结论稍微讲一下，好，在1分钟内结束，然后就换 Ann， 好吗？好，我知道你超认真的哈。好，你把它结束一下，好。
好，那 I'll try. I'll just jump to conclusion. So yes, as you can see, the slope is impossible, nearly impossible to see. See, y equals to s is this, and the slope is over here. So it's impossible to for you guys to see, and so jump straight to the conclusion. So since so yes, as you guys can see, if you guys can pay attention on the merge sort and the selection sort, you guys can see that actually merge sort is kind of fast and selection sort is kind of slow. However, in the graph we didn't see it that way because you see the merge sort is like the slowest since the rate of change is so big and the selection sort is so small. And why is that? I'll explain. Because since as you guys can see, this is the different time efficiency. So the higher of this is requiring more time, and this is this input size. So if the input size if the digit is more, then like it requires more time, right? So so the y-axis is time and the x-axis is the digit inputted. And okay, so as you guys can see, merge sort is O n log n, so it should be this one. Not that actually not that slow. However, selection sort is n squared. It's very very slow. It's very slow. But why does it like merge sort has a higher rate of change here? It's because of that. As you can see, if we break it down into a very small scale, like over here, if we zoom in over here, you guys can see that. Let me find it. So n log n near here is almost a straight line, and n squared here is almost a straight line here. But you guys can see, it's so hard to see, but you guys can see that at this instant rate of change, n log n has a higher rate of change than O n squared. So that's why over here, like merge sort will have a greater slope than selection sort, because at the instant here, that it's true that n log n will have a bigger slope. And for this point, like they all intersect. This is about 1,000, So it's impossible for my computer to run 1000 and show you guys the rest of the graph. So I can only show you guys like right in front of 1 here. So we can see that the instant rate of change is over here, like this. So that's why to sum up, that's why we use ON that's why we use ON instead of calculus to demonstrate the time efficiency of programs. So because it's too hard for like calculus to symbolize the time efficiency of the program. So yes, that's basically it. So thank you guys all, and that's my works cited page here. So yes, that's basically it. I tried my best to finish it quickly. Yes, thanks.
Okay, thank you, Professor Yang. 哎，你很优秀，很优秀，其实非常精彩，而且你这个已经就是基本上已经是资工系的实力了，非常好。好，那真的很精彩。那
谢谢。
好，没关系，我们在想要不要因为我刚刚在想说要不要让你礼拜3的时候有机会再把它讲得更完整一点。
其实我还要准备很多，可是都来不及讲。
好，没关系，我知道。好，没关系，那我们等一下再思考一下，先让你把它报告完。